Angela is on the line. Angela, are you there?
What? Yes, I'm here.
Hey, Angela.
Hi. So I would love to take this opportunity to introduce Joe Stubbs and the talk today. My name's Angela Newell, and I am the director of the Open Source Program Office. In the OSPO, we support researchers who are working with open source software. We offer consultations, events like this, and training. So if you ever need some help with that, I'm the person to connect with, and I'd be happy to help you. And I'm extremely excited today to introduce Joe. Dr. Joe Stubb leads the Cloud and Interactive Computing group at the Texas Advanced Computing Center, where he and his team build and maintain national scale cloud computing platforms and distributed systems for advanced research computing. He's also the PI of several NSF-funded grants, including TAPIS, and he leads TACC's involvement in the Icicle AI Institute. And we are really lucky at UT because Joe also teaches here in the Cockrell School of Engineering. He talks about software engineering, he talks about scalable system design, machine learning, and formal methods. Joe, thank you so much for spending time with us today. We are very excited to hear about collaborations and maintaining collaborations and TAPIS.
Great. Yeah, thank you so much, Angela, and thanks everybody for coming to the talk. I'm really excited to have been given an invitation to talk about this particular topic, sort of at least somewhat large scale open source software project that we've been running here for many years, depending on how you want to count, at least 6 years, but you'll see in the talk that it really is a lot more than that. So yeah, just a little bit of an introduction about me. So yeah, I'm a research scientist here at TACC. I lead the Cloud and Interactive Computing group, as Angela said. We're a fairly large research and development group, about 15 full-time staff. We also work with students. So at any given time, we usually have two, three, four students. I think we have three students right now at the time that we're working with. And as Angela said, I also teach classes in the computational engineering program in Cockrell. And yeah, I'm the PI of a few different NSF-funded projects, and in particular this TAPIS project that I'll be talking about today. Yeah, and in general, my interests, cloud computing, distributed systems, and applications of formal methods and machine learning. So this is going to be a little bit of a different kind of a talk than I usually give. So I hope it's interesting. But kind of what we're going to do is we're going to first start with an introduction to TAPIS. I feel like this is not going to be a technical talk, but it will be helpful, I think, to at least have some idea what TAPIS is about. But then we're going to kind of switch gears and we're going to sort of talk about how TAPIS started, sort of its origin story, and kind of what the guiding philosophy was around the project and why we chose to make it open source. And then I'll talk a little bit about the history of TAPIS, sort of its growth, its evolution, and a couple of important inflection points. And then I'll close with a little bit on sustainability, sort of the current status of the project, as well as some of our future plans. Okay, so let me begin with an introduction to TAPIS. So what is it? So generally at a high level, it's a API framework to support computational research, right? And it's domain agnostic. We're not focused on any specific domain of science, but instead what we're really trying to do is enable investigators to leverage computing across various different academic sites. Okay. And if you do have a sort of computational background, to get a little bit more technically precise, TAPIS is a set of hosted web APIs. They're designed in this RESTful style. If you know what that is, if you don't, that doesn't matter. But it's this sort of API framework, application programming interface framework, together with really an ecosystem of tools. And this ecosystem includes software development kits in different programming languages like Python, JavaScript, and Java. We have an official command line interface. And really the ultimate goal is sort of to enable researchers to securely manage data and execute code. Managing data and executing code. These are the two fundamental things that we're trying to enable folks to do. And these are sort of the high-level objectives that we're trying to achieve. And it starts with the first one. This is really the key. Programmable infrastructure. Right? We want to enable researchers to think of all of this different kind of infrastructure that they're working with, high-performance computing clusters, cloud computing clusters, various kinds of devices, and program them. So program complex experiments, workflows in an automated way. And we believe that once we have that, it leads directly to the second goal, which is this repeatability and reproducibility of the results that you're actually obtaining, right? So when you do something in TAPIS, any action that you take, TAPIS is recording a whole bunch of different information about the type of action that you took. It's recording, for instance, inputs that were used when you executed a piece of software. It's remembering things like what was in the execution environment, right? What versions of the software did you use? And again, the idea here is to make those computations repeatable and help you with reproducibility. And then finally, secure collaboration. So TAPIS provides fine-grained access controls on all of the resources that you create. So all of the files that you access, all of the applications, all the binaries that you register, and all of the jobs that you run, they come with access controls, which allow you to keep those objects private just to yourself, or to share them with individuals, maybe others in your lab, or with entire communities of researchers. So here's just a quick picture of what I'm trying to describe here. So down at the bottom, we have all of this sort of complicated and heterogeneous infrastructure. We have HPC systems like the ones we have down the hall here at TACC. We have clouds like Chameleon Cloud and Jetstream Cloud, as well as, of course, commercial clouds, public clouds like AWS. But increasingly, we also have edge devices and near edge devices like laptops and phones, as well as sensors like drones, cameras, weather sensors, other kinds of sensors. And so this infrastructure is distributed, it's heterogeneous. Each one comes with a different set of interfaces, protocols that they may communicate with. And what we're trying to do with TAPIS here in the middle is provide a singular, unified interface to all of that different infrastructure underneath. And so there are broadly kind of two ways folks interact with TAPIS. They write programs, sort of depicted here on the left. This is a sort of pseudocode. But this is the kind of thing that you can do with TAPIS. You can write a Python program that's going to transfer some data from one system to another. It's going to submit a job to run on some other system, and then it's going to download the results. All right. So you can write a program that instructs TAPIS to do a bunch of things with data and code across these different kinds of devices. And the other thing you can do is you can interact with a web application, a graphical interface, which of course under the hood is just Python code like this. But it's really providing you with a complete program, code-free way to interact with your infrastructure. And so that's really sort of in a nutshell the goal of what we're trying to do when we say we want to make the infrastructure programmable. And like I mentioned, we really want to support research across what we call the computing continuum, right? So not just big HPC clusters, but instruments and sensors. We want to support the entire computational life cycle. So once you get raw data off of those sensors, you usually need to do some kind of quality assurance, some kind of extract, transform, load processing. You may do machine learning actually as part of doing that ETL, but then you typically run some kind of big simulation. Traditionally, that was some kind of HPC simulation using OpenMP and MPI. More and more these days, that's an AI or machine learning workload. And then finally, sharing and publishing the data. So once you have actual results that you're wanting to disseminate to your community, you're wanting to manage those permissions. And so we're trying with TAPIS to enable this entire life cycle, if you will. Okay, so that's all I'm going to say actually about TAPIS, what it really is. Hopefully that gives you enough of a picture. But this talk is really about the open source project that was TAPIS. And so I'm going to start a little bit by talking about the origins. So really the origins of the TAPIS project date back to 2008 with something called the iPlant Collaborative. And I actually went to the Wayback Machine, to the Web Archive, and pulled up this picture. So actually this picture is circa 2014. But the iPlant Collaborative was a project that was funded by the NSF in 2008 with the express goal of creating cyber infrastructure for life science research and to democratize access to US supercomputing capabilities. So I just think it's amazing that was their mission, that was their mandate all the way back in 2008. And here we are in 2025. And really, of course, we've made a lot of progress on democratizing access, but this mission, this mandate is still as important as it was all that time ago. So iPlant was this really transformative, really future-looking project that provided this web portal. And there were different components to the portal. I'm mostly kind of thinking of the discovery environment, the DE, as it was sometimes known. And so essentially to accomplish that, to implement this iPlant Collaborative cyber infrastructure, there were three sort of primary components. Really, there were more components, and over time things got added. I'm simplifying, but there was a web portal, and then there was an API, an application programming interface underneath the portal that they called the Foundation API. And that Foundation API had apps it was aware of. These were the codes, these were the executables that could run on the supercomputing machines. And so the web portal would make requests to the Foundation API to run apps as specific jobs on the supercomputer. And so this, let's say, was truly transformative, this project. I just grabbed a couple of little stats here. More than 125,000 users, or 124,000 users, more than 1,600 publications from this project, and truly, a darling of the NSF and the OAC, the Office of OAC in particular. And so what happened was around 2013, we had the idea that what we should do is we should make a multi-tenant version of the Foundation API. I mean, in a nutshell, that's really what the idea was. It was like, hey, iPlant has been super successful, but it's really focused on plant biology. And there are a lot of other research groups that would love to have a similar cyber infrastructure, but focused on, whatever their research interest was, right? And, the iPlant had plant biology applications, it had plant biology data sets. And if you were an astronomer, or if you were a civil engineer, or, if you were a chemist, you didn't want those data sets and those codes. You wanted your own data sets and codes and tools and so forth. And so that was the idea, was, could we build a new version of Foundation that provided this sort of namespacing, right? This sort of logical separation of projects, so that it was relatively easy to add new projects and have them be isolated from each other. And again, not to get too technical, but if you kind of follow the logic of that, the next thing you're going to realize you need is a sort of flexible authentication mechanism, the ability to, log different kinds of users in. And so we knew we needed to do that. There was one specific authentication mechanism in Foundation that was based on LDAP directory that was run at the University of Arizona. And so, we needed to kind of redo the auth system. And we knew we also needed to improve DevOps, as it's called, sort of the development operations that go into getting new code out, right? And ensuring that the quality of that new code is still high. And that we knew would allow us to accept contributions from external folks if we had this sort of improved DevOps sort of system. And so this was the Agave project, actually, if you for those who may have heard of that word. It was funded in 2014 by the National Science Foundation. And it was again a 5-year project. And so, yeah, the Agave project and the Foundation API, all these things were open source from the very beginning. And there were, I don't want to speak for everyone on the iPlant team, but in my mind, there were broadly kind of 2 aspects to choosing open source. The first is that, one of the main goals of this whole thing was reproducibility, right? And the ability to kind of record and repeat the actions that are taken in the platform. And so, so we felt like transparency with Tapas itself was really important for achieving that goal. If you wanted to know really, truly what was done, then you needed to be able to look at the code and see what it was doing, right? Because in some cases, it was just kind of shoveling things from one place to another, but in some cases, it was actually doing things that were important to the actual results that were getting obtained. So yeah, from the sake of just transparency to support reproducibility, we felt like the project should be open source. But we also felt like open source was the right model for sustainability, right? I mean, we were, all sort of enamored by projects like GNU and Linux and Git and these open source projects that had just worldwide sustainment, basically. And our goal was to make it so that as many researchers as possible, as many institutions as possible, could be involved in the project, could contribute to the project. And so to us, open source is really a no-brainer. Okay, so I'll talk now about sort of the evolution of the project and kind of talk about some of its growth. So from 2014 to 2018, roughly, this is the V2, this is the Agave era, although we actually rebranded in 2017 as Tapas. But anyway, roughly speaking, this is the era of V2. And really it's marked by additional tenants. That was our goal, right? We had Foundation API. We wanted a multi-tenant sort of version of that. And we were largely successful. And so one of the big projects that came on really early on in that process was a project called Design Safe. So this was a major cyber infrastructure investment from the National Science Foundation. It initially launched in 2015. It was then renewed for 5 years in 2020, which takes us to now. And actually, it was planned to be renewed for 5 more years this year. There have been a few delays on that due to just the whole government challenges, but actually, it's been an extremely successful project, and we fully expect it will be renewed. But this was in very, very broad, high-level terms, similar in many ways to Cyverse. iPlant Collaborative, which also rebranded, but let me hold off on that. So this was very similar to iPlant Collaborative, but with a focus on natural hazards and civil engineering, structural engineering. And so So they used TAPIS v2 at that time as their backend, and it enabled them to connect not just to the TACC clusters and the high performance storage and computing machines, but also to what they call EFs, these experimental facilities that were really up and down the east and west coast. These are things like shake tables and wind tunnels and other kinds of civil engineering experimental facilities that generate simulation data that can be used for experiments. And yeah, we added several additional tenants over those years. So I mentioned iPlant rebranded itself actually as Cyverse, and that was around 2016, I believe. We had the drug discovery portal, which I believe had existed in some other kind of incarnation before this, but in 2016, roughly, it moved over to TAPIS v2. And then we had other projects like the Arabidopsis informatics portal, some may remember. We had the synergistic discovery and design. This was a really cool, large DARPA project that we participated in. It launched in 2017. It involved half a dozen or more institutions. And then we had projects like VDJ Server. I think it might have launched earlier than 2018, actually. But we had VDJ Server, which was kind of a relatively small project by comparison, sort of a one lab project, but a very impactful project that not only had impact on its community, but had impact on TAPIS because it was an early adopter and it was a provider of requirements from an early stage. And in some ways we were lucky. We were lucky because these projects were successful, and the success of these projects was directly translated into success for TAPIS itself. So I post this is off of the DesignSafe website, kind of just charting their success. You can see 50,000 jobs, 60 million core hours, more than 10,000 users. So this has been a tremendously successful project, and essentially all of this is TAPIS. I mean, this is TAPIS usage, not to take credit, but I'm just saying like all of this usage is directly translating into TAPIS usage, and that's making the project better, right? Yeah. So that brings us to kind of the sort of present era, I guess, if you want, which essentially dates to 2019. And this is what we call TAPIS v3. And again, we were very fortunate to get another 5-year grant, and then we got a supplement and extended it a year. So it actually, this grant just ended in September of this year. But in a nutshell, what we wanted to do with v3 was to make TAPIS multi-site. We knew that there were institutions that wanted to deploy TAPIS components on premise, and so we wanted to re-architect in a way that would allow institutions to deploy a subset of the components, not the entire platform, but a subset of the components on premise for performance reasons, but also for security reasons. And that would, again, grow the usage, grow the adoption of the platform. We also took the opportunity to really embrace some of the ways in which, the creative ways in which users were using v2. And this includes things like containerization of applications. So we were in v2, we were very much into containers from an early stage. And you could get TAPIS v2 to run your scientific software as a container. But it took some work, right? You had to actually kind of bend TAPIS a little bit to make it do the thing that you wanted to do. And so we wanted to have first class, what we call first class support for containerized applications. And so that was something that we tried to add in the v3 version. And we also added support for streaming data and some other things. And so It was a big decision, but we ultimately decided that V3 would be a separate instance. It would be a new platform, and that meant a couple of important things, actually. First, it meant we had to run both TAPIS V2 and TAPIS V3 at the same time. And it also meant that we started out with zero usage of TAPIS V3. And so this is plotting the growth of just TAPIS V3 starting in 2020. And you can see that we had 0 tenants and 0 gateways in 2020 and 0 users. But what's happened over the last 5 years or so is that we've had basically a linear growth in tenants and gateways. So we're up, multiple dozens of those. And we've had a sort of, especially in the last couple of years, an exponential growth in usage of the platform. And a lot of that has to do with folks getting off of V2, which was one of the biggest challenges that we faced retiring V2, which I'll talk a little bit about in a minute. But yeah, so that's one picture. Here's just a few more stats. So I didn't even bother plotting the early years because they were so small. But you can see that since 2023, especially, we've really had substantial growth. And I should say these are like academic years. So this is like, 2023 is really referring to, 9/1 to 8/31, 2023. But we had, 24 million API requests in that 2023 academic year, and we're at almost 150 million API requests at the close of 9/1 of this year. And similarly with jobs executed, and it's an academic project after all, so we have to talk about the papers we've published and the citations we have. Each of those metrics has really substantially stepped up over the last few years. Yeah, and we have a number of different projects that are using TAPIS at this point, funded by different agencies, a lot of different science gateways for sure, but also institutes, centers. So at this point, we really have a strong kind of user base that's quite diverse. Okay, so I will, Jen asked me to talk about at least one, interesting challenge. And I guess, the one that really stands out to me is migrating projects off of V2. And I think everyone probably, including myself, was aware that this was going to be difficult. But I still, I don't know, maybe I was just in denial. I still didn't really fully appreciate, what it was going to take. And so this is the sort of distillation here. Basically, the first release of V3 was in July of 2021. And, it wasn't like we had no usage at that time. We did have usage. In fact, we had a meeting at PERC, the PERC conference, where we had a bunch of early adopters who were on using the platform at this time, who came and spoke. A lot of PIs came and spoke. It was really nice of them. They were very supportive. But fast forward to July 2024, 3 years later, which was actually our planned retirement date for TAPIS V2, and we still had more than 15,000 active accounts, V2 accounts. And just an anecdote, I went back and looked at my email. I think I had blocked out some of this, but I personally sent literally thousands of emails. I counted. There were literally multiple thousand emails to a handful of projects about moving off of V2. There's still one thread in my history that won't load in Outlook because it's many hundreds of messages long. And this is not to disparage these groups. In fact, this was, an incredibly difficult part of this job for me personally. These were, my friends. These were my colleagues. These were people who had written letters of collaboration for us and us for them. We had a long history. We were asking them to make a big lift, to completely, change their their application. I won't say rewrite it entirely, but in some cases, there was a lot of rewriting involved. And yet, we really needed them to do this because it was just in the best interest for everyone. In fact, our security team eventually had to get involved because V2 ultimately became out of security compliance. And and that was just something that was kind of like the rubber is hitting the road here. We're going to have to get it. It's going to get pulled off the network. So anyway, this though was an incredible challenge, and I actually personally started to believe that some projects would never move. That's what I started to believe was, wow, this is never going to happen. And in fact, that turned out to be wrong. In the end, the projects did all move, which is really a testament to them. But okay, so now let me move to the final part of the talk. I'll talk about some of the inflection points and sort of our sustainability picture. So kind of looking back, I think these are sort of the big moments that stick out to me. Again, mostly focusing on this third phase. So July 2021 was a big year for us, or a big moment for us. It was this beta release and the initial release of V3, this early adopters meeting that I mentioned at PERC. At that point, it really was, at least we felt, feature complete. Like you can do everything that you could do in V2 in V3. We did call it a beta release. Like, there's probably going to be some things that have bugs. But we had several very supportive PIs. The A2CPS PI, I remember, came and spoke. The VDJ server PI came and spoke. They were with us from the very beginning, which was really important. And then also in that same month, the NSF agreed to fund this Icicle AI Institute, which was a very large, 5-year, $20 million, like 14 institutions project that, ultimately was proposing to build their, sort of advanced AI-based cyber infrastructure on TAPIS as the foundation, TAPIS V3. And so that really gave us a shot in the arm. It was like, okay, but we've got these early adopters, we've got this 5-year AI Institute, and yeah, we've got some runway now that we can make it. That was at a peak of sort of optimism. And then I would say the spring, really early spring, like February of 2022, the San Diego Supercomputer Center at UCSD decided they would like to deploy TAPIS V3 as a third site. So we had already had a site at the University of Hawaii. They were part of the project though. And so UCSD coming on really with virtually zero kind of knowledge of how TAPIS worked was a really big moment. And what happened was it was challenging. It was much more difficult than I think anyone expected to get TAPIS to run on their infrastructure. But we learned a whole lot, and we improved our platform a whole lot as a result of working with them. And they never gave up on us, which I will always be appreciative of. And so then, yeah, fast forward to summer, I think it was August of 2024, DesignSafe shut down its TAPIS V2 portion. And, I really had wondered that, so DesignSafe was kind of the biggest, most complicated CI tenant that was running on V2. And I thought, maybe DesignSafe won't ever be able to fully move. I had started to think that, but I give Tracy Brown and Ellen and Dan and Krishna and the whole DesignSafe team. I give them so much credit for actually making this happen. This was a very big moment because it made us realize, okay, if DesignSafe can do it, anybody can do it. And of course, it wasn't until a whole half year later that we actually were able to retire the last of the V2 servers. So it still took quite a bit of effort, but yeah, I said those are kind of the big moments. So let me kind of switch to sustainability here in the last part of the talk. And this is definitely something that we've been thinking about for quite a long time. Here's a paper I actually remembered that we wrote this paper. So this was at TACC, the Hawaii System Science Conference. So this is a paper from 2021 that we wrote on sustainability for TAPIS. And just to start with a couple of definitions, I mean, what do we mean? Well, to sustain software, what we mean is we want to ensure that it continues to be available and that it continues to be useful and usable, right? It has to work. And so sustainability then is the capacity of that software to endure and to remain useful over time, right? And so in my mind, my way of thinking about it, this is what we wrote in the paper. I went back and looked, and really, I think it's still my just super simplistic framework for how to think about it. But there's basically two categories of efforts you can do. You can try to reduce the resources that are required to sustain software, and you can try to increase the resources that are available to sustain software. So reduce the resources that are required, increase the resources that are available. And so those two categories, we sort of go at them both, equally. And I think that's part of the way we've been cyclical. So so on the reducing side, largely this is engineering effort, right? This is what can we do to embrace best practices, largely from industry, regarding the engineering of kind of large scale systems. And so I wrote down kind of, I guess, 5 of the big things that I think of that we've done. CI. So again, this will be a little bit technical, but continuous integration and sort of this automated pipeline for development in QA. This is one of the things that we've done. So every time you push a code change to a TAPIS repository, an automatic build runs. This automatic pipeline that will compile the code, if it's like a Java compiled code, it will package the code as a Docker container. It will run an automated test suite, and it will publish the containers, it should say, to the image registry, right? So it will run through all those steps, and if any step fails, the whole thing stops, and we get a big message that says the build is broken. And this is something that industry has done, for years, but it's an important part of reducing the sustainment effort, because we know that now, all the contributions that get made, whether they're made by the core team or somebody else, goes through this pipeline. Documentation sites and tutorials. So this is something we've invested a lot in. I think we have really high quality documentation sites. And in case you're wondering, yes, people do read those. They really do. And they find the problems with them. And we know they read them because they find when there are things that are wrong in there. But I think this greatly reduces the effort, the burden of answering users' tickets and questions. And so I think this is the kind of investment that there's a big ROI on. You write the documentation once, you point folks at that documentation, and they're smart people. They're often able to answer their questions that way. This is a little technical, but we have this specification language, this open standard called OpenAPI that we use to describe all of our endpoints. And that allows us to automate the generation of a lot of the different components of the sort of greater ecosystem. So like the language SDKs, the command line interface, and even our live docs website are all auto-generated just from these specifications. So that's a sort of nice big bang for the buck that we get. I would point Kubernetes container orchestration as another way that we reduce effort. So in V2, we didn't have Kubernetes, didn't exist. And so at the height of V2, we had 33 production servers. 33 different individual, most of them were virtual machines, but there were a few actual bare metal servers where we had to just write scripts to start up all the different Tapas containers. And Kubernetes broadly gives you a way to decouple the servers from the containers that you're running. And so today we have more than 120 containers running in production Tapas. And that number has grown. It wasn't always 120, but the use of Kubernetes allows us to scale the servers to meet the need of the platform, to grow as our workload grows. And then finally, I'll mention the monitoring and the alerts. So again, looking for places where you can put automation so that humans don't have to do something, right? And we have Prometheus, which is gathering a variety of metrics. We have Grafana that we're using to build dashboards and get insights from those metrics. And we have Splunk. We're looking to have an enterprise site license here where we're doing log aggregation and additional kind of metrics and alerting from that. Okay, and then increasing the resources available. Well, so I mentioned the open source ecosystem, and this is a big part of getting more people with eyes on the project. So all the code is hosted on GitHub, and this includes, by the way, like the documentation sites. And so, anyone can go and look at the code. They can contribute to the code. They can actually see what's on the roadmap in terms of new feature bug fixes, because those are issues on GitHub. And we have this support for multi-site deployments. And we now have a 4th site going up at UCLA. But each time we have a site adopt the code, it just means an additional set of system administrators, software developers, engineers, getting their eyes and hands on the code, and usually finding things that aren't quite right. And occasionally they also contribute back, but even if they don't ever make a code commit, just the fact that they've put their hands on the code and maybe gotten something to work, but maybe also had some experience with some issues, and pinpointing that makes the platform better. So the other effort, really in the sort of increasing resources bucket is additional grants. At the end of the day, writing and maintaining software takes money. So, so we have to have money to do this. And there are a couple of different types of grants that we go after. So on the first type, we just have projects that want a little extra consulting time from Tapas. And so this scoped project is an example of that. This is a seismology based portal, Science Gateway and portal. And so they'll write us in for not a lot of money necessarily, but the scoped project is funding a graduate student that's been working on Tapas, and also a little bit of some of the senior developer time to mentor them. And then we have research efforts that actually extend Tapas. They kind of build on top of Tapas. And so I mentioned this Icicle AI Institute that we're a part of. I'm the PI of a new award that just got funded in September. It's a CC award where we're looking at building a security policy analyzer tool. And we're using Tapas as the data source, the test bed. So that's another example where we're basically building on top of what is there. Okay, so I'm almost done here. Two more slides. I want to say that the current status of the project is really bright, and that is in large part because of the tremendous institutional support that we have here at TACC and at UT Austin. I sometimes think there are very few places where this project could be successful because it's expensive. It's a big, expensive project to run, but we're extremely fortunate to have the support that we have. We have, Tapas runs on clusters that my team runs that are mostly filled with retired HPC hardware, just as one starting point. The leadership class computing facility directly funds TAPIS work because TAPIS is part of the broader LCCF ecosystem, and that's a long, term grant that will directly fund TAPIS development in a substantial way. The UTRC grant, which is funded by UT System, has provided substantial support for TAPIS. So there's literally grants that have been contributed, but it's also really important to point out that TAPIS really benefits from direct and indirect support from all the groups at TACC. And I really want to underscore this. So for instance, our security team, our network and security team, they run center-wide networking and monitoring software and hardware, which TAPIS benefits from tremendously, right? They've done security audits of the TAPIS software. The LSS team has worked to ensure that there's compatibility between HPC clusters and TAPIS. The HPC group and the life sciences group have developed tons of portals and applications that TAPIS makes use of. The data group has provided high performance storage. They've built us, we still to this day have high performance databases that we use directly in TAPIS that they've built for us. And on and on. The user services, the accounting groups work with us to make sure accounting and allocations work well. And of course, the web portals team, our web developers have really been the sort of power users of TAPIS and have built dozens literally of portals on top of it and have really provided a lot of support. So I think this is my last slide. Our future plans. So, we think, like I said, we have this great, we feel like we have this really solid foundation to carry us into the future. We think that provides this sort of interesting platform for doing new kinds of work, like the security policy analyzer that I mentioned was just funded. We have been working in Icicle on doing sort of intelligent data transfer and intelligent job scheduling, so using AI and machine learning. And we now have a growing data set of historical, data movement and job scheduling that we can use to train. And we do have some papers on that. And then also just expanding what we have to support additional kinds of research, additional kinds of computational workloads. So naturally, AI and machine learning is a big part of what we're doing, agentic components, but also IoT, edge and field computing, so including robotics and digital twins. These are all things that we are actively exploring support for at different levels. Okay, so I think that's it. Hopefully I didn't go too far over. Thanks everybody. It was great to be here, and I'm happy to take any questions if you have them. Yes.
Yeah, a couple of things. One, I appreciate you clarifying your relationship with GitHub. You guys use GitHub obviously quite a bit, and I'm a biologist, so a lot of this went over my head. My colleague on this project that we work on, he's really the computer, expert in everything, APIs and open source and all. And it's a huge database project. It's a biological database project. How many of those 15,000 folks, how many are biological? A lot of them biological related?
Yeah, that's a really good question. Yes, I would say so. Historically, we have had a lot of usage from the biology community, life sciences community. What portion I'm not entirely sure. But I would guess. So I mean, a big portion is design safe, which is an engineering. So a lot of our users come through that. I will say, but I would say that a big portion of probably the majority of users who don't come through design safe are life sciences people. Yeah. So I mean, it may be close to 50%.
Wow. Okay.
Yeah.
Yeah.
It's been a really important, part of our, the other thing to keep in mind is it's not necessarily just about the the number of users. A project like Airport or SD2, which is a synthetic design project, may have only had, a couple hundred users in that community. But the project sort of adopting TAPIS and getting it to work and working with us on things that didn't maybe work as well, initially, that's equally important, and so I think that's the other thing to say is that there have been a lot in number of projects from the life sciences, as much as there's just the sheer number of users.
Yeah, so any one individual user or group could be a very small, it could be a very small project, very small operation, right?
That's right.
Your 15,000 different that number so any one group, any one project could be fairly small. Right?
It could be, yes, absolutely. So I don't know what the VDJ server user base is. It's actually grown. It's probably several hundred now at this point. It may even be more than that. It may be into the thousands. But yeah, there's so the Icicle. So to have an example, like the Icicle AI Institute, it's a relatively small number of actual individual people using TAPIS.
Yeah.
Researchers from a bunch of different institutions doing a bunch of different kinds of things, but it may be, all told 100 or so users coming through that whole project. But it's still been immensely valuable because those people have, again, pushed TAPIS in different ways. They've actually contributed to TAPIS in different ways. And so, a lot of the capabilities have evolved, even though the actual number of individuals may not have been as big.
Yes, no way of knowing the real number, but how many people use TAPIS that don't know they're using TAPIS?
Yes.
Right. If you build a portal using TAPIS and present that, you could have 1,000 users, and not a single one has any idea that TAPIS.
Yes. And that's right. And we of course know the numbers because we can look them up in the database, but we have kind of publicly available tenants. We have namespaces that aren't, that aren't prescribed to specific projects that anyone with a TACC account, for example, can come and use. And so oftentimes we hear about projects that are using TAPIS only when something doesn't work. So there was a group at the University of Minnesota a couple months back that was using a supercomputer in I think it was at PSC, at Pittsburgh Supercomputing. And actually the TAPIS support for Pitzer, that HPC system, stopped working due to a change that they made at Pitzer, the system admins made. And that's when we came to know that this group at Minnesota was using TAPIS to do this. So I actually love that. I love that people can just start using the thing and then it works, until it doesn't. But yeah, most of the people who are using the platform, we know about them, but occasionally there are groups like that. Yeah.
Is there a website for TAPIS?
Yes, I should have put that. Sorry. Yeah, there are several, but you can go to tapis-project.org. Maybe I can put it in the chat. This computer.
Joe, while you're doing that, do you mind if I make a quick announcement?
No. Yeah.
Hello, everyone. This is Tabish Khan, just letting you know about some of our upcoming classes for summer 2026. We have our TACC Summer Institute coming up again, and this includes classes such as machine learning for life sciences, data curation and management, and data-driven decision support. These will all be open for registration January 14th, so please keep an eye on our registration page. And then thank you as well for attending our class today. We hope you have some good takeaways, and welcome any follow-up questions that you might have. Just email me or Joe Stubbs. A recording for this class will be available in the lobby that you joined from. And if you would like a copy of the slides, just shoot me an email and I'll get those over to you as well. Thank you.
Yes.
Okay, again, full disclosure, I am not a computer person. I know enough to get by. I'm with Research Security.
Okay.
I know you mentioned security compliance and a cloud security analyzer tool, so I have a couple questions.
Sure.
I'm assuming this security is sort of IT computer-centered security. Is there any sort of screening or way for you to know what sort of projects are on there and what the security requirements, like regulatory security requirements, need to be satisfied? Or are you just like export control, CUI compliant, and you don't worry about it?
No, yeah, that's a great question. The short answer is it's hard to know for sure everything that's going on, you know.
And if I can help, let me know.
Yeah, well, yeah, I would love to have a, in-depth discussion, you mentioned export control and like, PHI, these things are really important, and kind of like at the end of the day, TAPIS really doesn't enable you to do anything that you couldn't already do without it, at some level. But it does allow you to do it at a scale, and in an automated way that you maybe wouldn't be able to do as easily without it. So yeah, I mean, all of these things are important, and we, what we ultimately try to do, what our focus is for the most part, is on TAPIS itself. Is TAPIS, adhering to the security rules that it has in place for itself? So as I said, TAPIS shouldn't allow somebody else to do something on, somebody else's behalf unless that user has authorized it through TAPIS, right? So we've done security audits, both, from our in-house, from our security office here at TACC, as well as external. We've had external groups like Trusted CI. This is an NSF Cybersecurity Center of Excellence, has done a security audit of TAPIS to make sure that TAPIS itself is, kind of complying with rules and regulations. But is it possible that a project could come on and use TAPIS in a way that is not in compliance with, whatever regulation? I think yes. I think strictly speaking, the answer is yes. And so we have to be, careful about that. This is one of the motivations for a project like the Security Policy Analyzer tool, right? I mean, inside TAPIS, projects go and configure security policies. Like, no one should be able to read Joe's private data except Joe. But is it possible that projects have misconfigured policies, that have written, incorrect policies in TAPIS? Yes, that is definitely possible. And so that's something we're working on, helping them, like with projects like this, to have tools that they can use to analyze the policies they've written and try to determine if there might be some discrepancy.
Yeah, I mean, the Cloud Security Analyzer tool, if it were configured for export control, that could replace me and I could retire.
Don't worry. I don't think there's not.
I'm just waiting for it.
Yeah.
It's making my job easier.
I mean, I do think there are automated things we can do, and CloudSec's using AI as well as formal methods to try to automate some of the analysis. but it is still a very difficult problem. It's still very much human in the loop as part of this tool, you know, so
Yeah.
it's a research project for
I mean, ultimately, if you've got all your security in place, it's on the PI if they
That's
put
right.
it on a non-compliant space. But if I can help with anything,
Okay, great, yeah.
I'll catch you up.
Let's have a deeper discussion, that'd be great, yeah.
All right, before we go too far over time, let's go ahead and finish it. And any other follow-up questions, they can send you over email, Joe.
Absolutely.
All right, sounds good.
Thank you very much.
All right, thank you everyone for joining. I hope you all have a great weekend.